Imagine a heavy ship sailing entirely blind into a massive, violent storm. High up in the crow's nest, the lookout sees the danger ahead. He grabs his radio, screaming a warning to the crew below to turn the wheel before it's too late. But down in the steering room, the crew hears nothing. All that comes through the speakers is dead air and static. Because the message never arrives, the crew keeps the ship on its original path, straight into the crashing waves. This specific type of communication failure is what a team of researchers found when they looked at how stress leads to relapse. We've known for a long time that high-pressure events, like losing a job or a difficult breakup, are the most common reasons people return to drinking. We could see that stress caused the relapse, but for years we couldn't see the actual physical pathway in the brain that was breaking down. A new study has finally identified the specific physical connection that stops working during these moments. To see why that matters, we have to look at how the brain's alarm system talks to its control center, and what happens when alcohol cuts the line. First, there's the lookout. This part of the brain acts as our alarm center, sensing stress and alerting the body. Then there's the steering room, a region further inside the brain that handles our actions. This control center decides how we react. It can either help us stay flexible and try something new to solve a problem, or it can let us fall back on our oldest, most rigid habits. To get through a stressful day safely, the alarm center has to be able to talk directly to the steering room. Researchers recently discovered that there is a direct physical wire connecting these two areas, a dedicated line for stress alerts. When you feel pressure, the alarm center sends a specific stress chemical down this wire. Think of this chemical as the radio signal that carries the warning. These images show the proof. By using special glowing markers, the scientists traced the path and found these overlaps, confirming that the alarm center and steering room are physically linked. This chemical signal is the only way the steering room knows that danger is coming and that it needs to change course. Inside that steering room, there are specialized cells that wait for that stress signal. We can think of them as the steering crew. In a normal, healthy brain, when the stress chemical hits these cells, they wake up and start working much harder. That extra work releases a second chemical that tells the brain, stop and think, be flexible, don't just do what you always do. The data shows this happening in real time. When that stress chemical is applied to these cells, their firing frequency, their level of activity, shoots way up. This connection is what allows us to stay in control and adapt when life gets difficult. But then, the researchers shifted their focus and looked at what exactly happens when this specific circuit is exposed to alcohol. They found that alcohol acts like a physical radio jammer. It blunts the steering crew's ability to hear that stress signal, even long after the drink is gone. Look at what happens to the cell's activity here. When alcohol is present, that firing rate, the crew's response, takes a major dip. They can no longer ramp up their activity to handle the stress. Alcohol essentially deafens the steering room. The warning is sent, but the crew never hears it. Now imagine someone in recovery having an incredibly stressful day. Their alarm center is screaming that they are in trouble, but because of the damage from alcohol, the steering room hears only static. When the steering room is deaf, it can't be flexible. Instead, the brain defaults to its strongest, most rigid habit to cope with the pain. For someone with an addiction, that automatic, rigid habit is reaching for a drink. This shows us that relapse isn't a failure of willpower. It's a message that didn't get through. By finding this jammed signal, we finally have a specific target for new treatments that could help people stay sober by restoring their brain's ability to listen.